So, what you are going to be doing today and tomorrow is starting the process of verifying trig identities. So, you should have received the identity it's like a formula sheet, little cheat sheet thing. Um, all of those identities will be given to you on the next quiz. They'll be given to you on test 2. They'll be given to you on the final exam. So you do not have to memorize the identities that are there. Now, some of them you should already know, like the reciprocal identities, quotient identities, and at least the first Pythagorean identity. In this section, we are only working with the identities that are in the top section of the sheet that you received. The sum and difference formulas are in the next section, and then the section after that, you have double angle and half angle formulas. So you won't have to use all of them yet, just the top section for this homework. All right, so what I've done here up at the top for you to write down are just some tips. Again, it doesn't mean we're always going to do every identity this way. These are just some general, ideas that may help you. It is okay to work with both sides, but we generally try to only use one if we can. If we can't, sometimes, and I'll show you, examples of this, sometimes we get stuck. And so we kind of have to manipulate both sides in order to get it to verify the way that we want. So we generally try to work with just one side if we can. I almost always try to start with the more complicated looking side and manipulate it until it looks like the more simple side. Then I have some general strategies that you're going to see me use. I'm going to do a lot of examples here so that hopefully you see how we use these. Now, being upfront and honest, every trig identity is different. It's kind of like a proof. So like in geometry, your teacher could show you an example of a triangle proof, but every proof was a little bit different and you had to figure out, with problem solving how to do it. It's going to be the exact same for these trig identities. They are all going to be different. And so we're not going to be able to do an example of every single thing that we're going to see. Also, something general to say that's important is if you are positive that you got it to verify, that you used substitutions that are math legal, and yours looks different than mine or than your friends, that is okay. Sometimes what I think to do to manipulate something and what you think to do to manipulate something are going to be different. In fact, there are some that I did in the homework that, I've seen someone that did it a different way, and I actually like their way better than mine. So again, just because it's different doesn't mean it's wrong. So you can feel confident if you've only used the substitutions that are on your formula sheet and you got it to work, then you're fine, even if it's different than mine. Okay, so what I'm going to do is all of the homework problems are pretty much going to have the same directions. So what we're doing, excuse me, is we are verifying the identities, which again, it's kind of like a proof. So the first example that we're going to do is we have sine squared x times 1 plus cotangent squared x equals 1. So, what we are trying to do is we are trying to manipulate and make substitutions so that things work out the way that we want them to. And again, everyone is different. So, if you see it a different way, that's okay. You might still be right. When I look at my identity sheet, the thing that popped out first to me is this right here. 1 plus cotangent squared x is in the Pythagorean identity section as being equal to cosecant squared x. So that's going to be my first step, and I'm going to put left, so I put L circle to mean left side is now going to be equal to sine squared x times cosecant squared x. So again, I used an acceptable identity. This is equal to this. Now I'm going to use one of my strategies, and I'm going to write everything in terms of sine and cosine. So sine squared is already in terms of sine. Cosecant squared, cosecant is the reciprocal of sine. So if I make that substitution, cosecant squared is the same as 1 over sine squared. So then I have sine squared times 1 over sine squared, which does equal 1, which equals the right side. So that now gives me something that's equivalent to the right side, which means that my proof is done. I have verified that this on the left side is indeed equal to this on the right side. So they're like little baby mini proofs. All right, so now we're going to take a look at another one. And again, they're all different, so I'm just going to try to give you a wide variety that hopefully will help you and give you lots of strategies to try for the homework. Okay, so next one that we're going to do is tangent x cosecant x cosine x equals 1. So again, we are trying to work with just one side, trying to start with the more complicated side, which in this case is the left side. So I'm going to, again, use the same strategy that we used in the first one, that I'm going to try to rewrite everything in terms of sine and cosine. So tangent is sine divided by cosine. Cosecant is 1 over sine, and cosine is just itself. So if we look at this multiplication, what we end up seeing is that we have a lot of things that cross-reduce. This sine x can cancel with this sine x in the denominator. This cosine x in the denominator cancels with this cosine x that would be in the numerator, because of course if no denominator is written, it's understood to be a 1. And so what we end up with is 1 over 1, which is the right side. So we've shown that that equals the right side, and we're done. All right, so far these haven't been too taxing. Had some kind of easy ones here. There won't be a ton of easy ones, but we'll do one more easy one before we get into the more complicated ones. So next one we're going to do is secant x minus secant x sine squared x equals cosine x. So more complicated side is definitely the left side again. So I'm going to start with that. This one, and again, I can't, just like with proofs, your geometry teacher couldn't teach you how to think. She or he could just kind of show you patterns and hope that you catch on. Same thing here. When I look at this one, the strategy that I immediately see is to factor, because both of these terms have a secant x in them. And so if I factor out the secant x, I get 1 minus sine squared x. Doing that does lead me on a path where I'm going to be able to manipulate more. If I look at my list of identities under Pythagorean identities, we see that sine squared x plus cosine squared x equals 1. If I manipulate that identity, I can make it look like 1 minus sine squared x by subtracting sine squared x on both sides, which means that if I did that, what I would have is cosine squared x. So this guy right here is equivalent to cosine squared x. So that means my next step would look like this. Then I use the first strategy again. Secant x is 1 over the cosine of x. So then I have 1 over cosine x times cosine squared x. Remember, if no denominator is written, it's understood to be a 1. And so what happens then is this cosine cancels one of the cosines in the numerator. So it's no longer squared, it's just plain cosine x. So I have cosine x in the numerator, I have 1 in the denominator, which does give me cosine x, which is equal to the right side. And so we're finished. Okay, next one, example D. We have cosine squared x minus sine squared x over 1 minus tangent squared x equals cosine squared x. Okay, so when I look at this one, my eyes are drawn to 1 minus tangent squared, and I look at those Pythagorean identities and I see, oh, 1 minus tangent squared, and then I'm disappointed because the Pythagorean identity says 1 plus tangent squared, not 1 minus tangent squared. So that means that I can't use that Pythagorean identity. We've got kind of a lot of complicated looking stuff on this left side. Cosine squared minus sine squared also isn't a Pythagorean identity. It would have to be a plus. So we're going to have to use a new strategy here. And what I'm going to do is use the last strategy, which is pretty common when you have like a 1 minus something or a 1 plus something in the denominator, and it's not directly one of the identities. Again, if this had been 1 plus tangent squared x, then we would just make that substitution down here. But if what you have in the denominator is not one of those identities, and it's in this format, generally the strategy we're going to use is going to be to multiply the top and bottom by a factor that's equal to 1 that allows us to manipulate that denominator. So I'm going to rewrite out my left side so that I can write the original and what I'm going to multiply by next to each other. Generally, when we have this setup, what we multiply by is like the conjugate. The two terms are the same, but we change the sign in the middle. So I'm going to multiply the top and bottom by 1 plus tangent squared x. And so what that does for me is in the denominator, I've got 1 plus tangent squared times 1 minus tangent squared. That's a sum and difference pattern. So when I multiply them with each other, we could cancel them out. So I'm going to write 1 minus tangent squared times 1 plus tangent squared. And so that might help me. The other thing that helps is this that I'm multiplying by is one of my Pythagorean identities. It is the same on your identity sheet as secant squared. So up on the top, I don't really want to FOIL all that out. So I'm going to change this to secant squared, which that's allowed because 1 plus tangent squared is equivalent to secant squared. So I'm still multiplying by a factor that's equal to 1. And what that gives me then on the top is I have secant squared x cosine squared x, because I'm distributing the secant squared, minus secant squared x sine squared x. And so then I'm going to manipulate the top because secant is the reciprocal of cosine. That means that this is really 1 over cosine squared times cosine squared, and then minus sine squared over cosine squared. Because again, secant squared is 1 over cosine squared. So the cosine squared goes in the denominator. The sine squared that we were multiplying by goes in the numerator. So our denominator hasn't changed. 1 minus tangent squared times 1 plus tangent squared. Okay, so what that does is cosine squared x in the denominator times cosine squared x in the numerator. Those cancel each other out. That just gives me a 1. Over here, sine squared x over cosine squared x. That can be changed as well, because sine over cosine, I know from my quotient identities, is the same as tangent, which means that sine squared over cosine squared is the same as tangent squared. So that top, when I multiplied by the secant squared, actually gave me 1 minus tangent squared, which is extremely helpful because that cancels then with the 1 minus tangent squared that's in my denominator. So this and this cancel out. So I have 1 over 1 plus tangent squared x, which 1 plus tangent squared x is what I had hoped it would be in the beginning, because 1 plus tangent squared x is one of our identities, and that is equal to secant squared. So 1 over secant squared x is what I have next. So this is saying the reciprocal of secant squared. Well, the reciprocal of secant is cosine. So the reciprocal of secant squared then is the same as cosine squared, which is exactly what my right side is. So equals right side, which means I have verified. Again, you can see much more work here. And as I said earlier, if you do a verification differently and you didn't make up your own identities to use, you used only the ones, on the sheet, then that's fine. If you did it different, you still got it to come out. That's great. All right, next one. Secant t plus 1 over tangent t equals tangent t over secant t minus 1. Now, in this case, both of these look somewhat complicated, and so you're really not sure, okay, which side is more complicated, which side is less complicated, and you may not really be sure, and so that's fine. So because I'm not sure which one is more complicated, I am going to just start on the left side, see what I can do, and when I get stuck, if I get stuck, then we'll go ahead and work with the other side as well if we need to. So I'm going to start out on this one. When I look at my strategies, I'm going to start in the separating quotients into multiple terms. So I have secant t plus 1 over tangent t. So that means both of these items are divided by the same thing. So I'm going to separate it into secant t over tangent t plus 1 over tangent t. So new strategy being used here. Then I am going to rewrite these in terms of sine and cosine. So secant is the reciprocal of cosine. So I'm going to substitute 1 over cosine t for it. Tangent is sine divided by cosine. And then, of course, the reciprocal of tangent is going to be cotangent. Simplify again. I'm going to put this guy in parentheses because I've got 1 over cosine divided by sine over cosine, which is the same as multiplying by cosine over sine. So what I have in parentheses here is now the same as what I have over here. Then cotangent, I know, is equal to cosine. Oops, why did I put cotangent x? It should have been t. Whoops-a-daisy. So I know cotangent t is the same as cosine t divided by sine t. So over here in the parentheses, the cosines cancel out. I've got 1 over sine t plus cosine over sine t. And so then because they have the same denominator, that means that I've got 1 plus cosine t over sine t, which I've kind of simplified as much as I can think to simplify, and this definitely still doesn't look like what I have over here. So when this happens and you're like, ugh, this looks a lot simpler, but it's not the same, it's not verified yet, it's usually because both sides were pretty complicated to begin with. And so in those cases, we can't help but have to manipulate both sides. So I basically abandon ship on the left side, leave it like this, and now start with my right side. So I'm going to say right side equals. So I've got tangent t over secant t minus 1. This one I don't have two values in the numerator, so I can't use the same strategy I did on the left side. So I can use one of two strategies here. I can multiply by a factor like we did over here, or you could also try the writing everything in terms of sine and cosine. In this case, it really wouldn't matter, I don't think, because either way, you're going to have to do both things. So I'm going to start with the multiplying by a factor that's equal to 1. And so like I just showed you in the previous example, what I do is, because this is secant t minus 1, which is not one of our identities, I'm going to multiply kind of by the conjugate, which would be secant t plus 1. So secant t plus 1, whatever I do to the denominator, I also have to be doing to the numerator, because again, we have to multiply by a factor that's equal to 1. Because then we're not changing the value. So this over itself is equal to 1. So we're going to multiply by this. And so then that gives me on the top tangent t secant t plus tangent t. In the bottom, I am going to get this time I'm going to actually multiply them out. And so what I end up with when I FOIL them, secant t times secant t is secant squared t. And then my outsides and insides are positive secant t and negative secant t. They cancel each other out, so I don't need to write those. And then negative 1 times 1 for the lasts would be minus 1. And so then, continuing to simplify, on the top, tangent, I'm going to rewrite this in terms of sine and cosine. So tangent is sine t over cosine t. Secant is 1 over cosine t plus sine t over cosine t on the bottom. Secant squared t minus 1 is a manipulation of the middle Pythagorean identity. The middle Pythagorean identity says 1 plus tangent squared equals secant squared. So if you subtracted 1 on both sides there, you'd have secant squared minus 1 equals tangent squared. So, you know what? Again, sometimes you think of better options. I'm actually going to cross this out. Sorry, because you've already written that too. I am going to leave this. And I'm actually going to refactor out the tangent. So as if I hadn't distributed, I'm going to leave it like that. The reason why is because I now see that my denominator is tangent squared t, which means that this tangent in the numerator is going to cancel with this tangent in the denominator, and that's going to make my life a little bit simpler. So now what I have is secant t plus 1 over tangent t, which, lo and behold, that would have been my original left side. So what this shows you here is that I started with the left side, and if I had started with the right side, it would have been a lot less work. Because what I actually just did is I manipulated the right side and I got the original left side. So that means I actually didn't need any of this work here, and this will happen to you as well. Sometimes you find something and you're like, oh, I should have done that. And so now this is equal to the left side, which means all I needed was this work to get it to verify. And we're done. Okay. Definitely D and E are the longest ones. So we're going to end with a couple more shorter ones. Again, I'm just trying to show you a wide variety so that you have lots of different strategies to try. So we're on F here, which is sine squared x minus cosine squared x equals 2 sine squared x minus 1. All right, so again, neither side really looks a lot more complicated than the other. If I start with the left side, I can see that my right side doesn't have any cosine squareds. So if I'm starting with the left side, I definitely want to make a substitution for cosine squared to get it in terms of sine squared, which we can do with our Pythagorean identity. Pythagorean identity says sine squared plus cosine squared equals 1, which means that cosine squared is the same as 1 minus sine squared. So I substitute 1 minus sine squared in place of the cosine squared. So these are the same thing. So all I've done is manipulated that on the left. When I do that, then I have sine squared x minus 1 plus, because I'm distributing the negative, sine squared x, which these guys are like terms. If I have one of it and I add another, that gives me 2. So I now have 2 sine squared x minus 1, which is the right side. And we're done. Told you that D and E would be the worst ones. So now, last one is G. We have secant theta minus cosine theta equals tangent theta times sine theta. Okay, so again, probably really doesn't matter which side you start with here, and we may find out in some cases that whatever side we started with, like we did in E, maybe wasn't the right choice. So I'm going to start with the left, and we'll see how it works. So left side, secant minus cosine, none of these are squareds, so no Pythagorean identities are popping out, so I'm going to try the strategy of writing in terms of sine and cosine. So secant theta is 1 over cosine theta. Now I'm going to use a strategy I haven't used yet. I'm trying to show you all of them. So we've done everything except the second to last one, which is combine fractions with common denominators. So here I need a common denominator of cosine, which means that this one's okay. It can stay as is. But over here, I would need to multiply both the top and bottom times cosine theta in order to have that same denominator. So of course I get cosine theta in the denominator. In the numerator, that gives me cosine squared theta. So this one already had the right denominator, so we do 1 minus cosine times cosine is cosine squared. Then 1 minus cosine squared, I can use my Pythagorean identity. That's the same as sine squared over cosine. Now be careful here. You know, you may be trained from Algebra 2 and from what we did with the unit circle trig to say, oh, sine over cosine tangent. Not true here because my sine squared, my cosine is not squared. So don't write equals tangent squared. What we can do, though, however, is use the fact that we know sine over cosine is tangent and we need a tangent to rewrite this as what we had. we can kind of break it back apart in a different way. Sine squared is sine times sine. Cosine times 1 is cosine. So this is the same as this, which I now know sine over cosine is equal to tangent. So if this is tangent, this is now the same as tangent times sine, which is my right side. So I was able to make it verify using and manipulating only one side. Okay. I know you're probably like, oh my gosh, this is going to be really hard. And again, it's really just like proofs. These verifies really are proofs. Every single one is different. You have to just keep trying things. If one strategy that you used didn't work, then you need to pick a different strategy. So we are spending 2 days on this, but there aren't additional notes. This is it. I just want you to have ample time to give good attempts on these. You're going to need to spend a lot of time on these problems. So it says on your schedule 2 days for verifying trig identities. So you need to try some of these, the page 658 assignment. You need to do some of these tonight. And then you also have class time tomorrow to continue working on them and trying to get them to verify the way that we need them to. All right, that is it for this lesson.